Kinematics equation 3. We can combine the two equations we've been working with, kinematics equations 1 and 2, to get kinematics equation 3. In doing so, we can eliminate time from the equation. If you solve both kinematics equations 1 and 2 for time and then set them equal to each other, then you solve for v squared. That's how you get kinematics equation 3. We won't show the algebra here, but it is great to do on your own if you would like practice with solving systems of linear equations. The result of doing this is kinematics equation 3. V squared equals v naught squared plus 2a times change in position. This equation is very handy for situations where we're not given any information about time or asked about time. Once again, this equation includes x subscripts for the vector quantities. Only acceleration and velocity in the x dimension will affect an object's position in the x dimension. We will not be trying to graph this equation. We're only going to use it algebraically. However, in any kinematics problem, this equation will also hold true. An object accelerates from rest with a constant acceleration of 7.5 meters per second squared. How fast will it be traveling after it goes 21 meters? Alright, so our givens. We have our initial position of 0, our initial velocity of 0, because it starts from rest, our final position of 21 meters, our acceleration of 7.5 meters per second squared. We are solving for velocity. As you can see, time is nowhere to be found in this whole problem. That's your hint that it's kinematics equation 3. So the first term goes away since v naught is 0. X naught is also 0, so that goes away. V squared equals 2ax. Take the square root of both sides, and we get the square root of 2ax. Plug in your numbers. Your velocity is 17.8 meters per second. An object accelerates from rest to a speed of 24 meters per second over a distance of 56 meters. What acceleration did it experience? Here are our givens. Our initial position is 0, our initial velocity is 0, our final position is 56 meters, our final velocity is 24 meters per second. So, no time. Let's go to kinematics equation 3 and solve for a. So first we eliminate that term and that term because they're both 0. So we get v squared equals 2ax. We are solving for a, so therefore we're going to divide by 2x. So that goes to the other side. A equals v squared over 2x. Plug in your givens and you get 5 meters per second squared. An object experiences an acceleration of 6.8 meters per second squared. As a result, it accelerates from rest to 24 meters per second. What distance did it travel during that acceleration? Here are our givens. Let's assume we start at the origin, 0 meters. Our initial velocity, also 0 meters per second. Acceleration is 6.8, velocity is 24. No time. We're not asked about time. We're not given any time information. We are using kinematics equation 3. This term is 0. That term is also 0. We're going to solve for x. So we get v squared equals 2ax. Divide both sides by 2a. Plug in our givens. Don't forget to square that velocity, and we get 42.4 meters.